All right, let's do an example of finding a derivative of a function at a point. So that means like the specific slope of a tangent line, specific tangent line at a specific point on the graph of the function. And we're going to do it with a limit. So using the definition, here's our function, f of x equals 3 over x squared. And the point in question is a equals 3. I think in the previous video, I called it C. Sometimes we use A. It doesn't matter. Those letters near the beginning of the alphabet are often used for constants, not to be confused with variables, for which we use letters at the end of the alphabet. All right, so I'm just going to write down the definition of the derivative. Oh, sorry. Before I do that, let's actually just write f prime of 3. That's what we're looking for here. It's going to be the limit as h approaches 0 of f of 3 plus h minus f of 3, and then all over h. Now, I need to actually go ahead and figure out what's going to go in these places. So I'm actually going to go ahead and get f of 3 plus h on its own and f of 3 on its own, and then I can put those pieces in the right places. So I'm looking at the function here. Function's defined like this, 3 divided by x squared. So I would write 3 divided by x squared. But in place of x, I put 3 plus h. This is how you evaluate a function with the input 3 plus h. You have to replace the x with the 3 plus h. Important that you put the plus h in the right place. Plus h goes inside the function. Okay, now I could rewrite that as 3 over 9 plus 6h plus h squared. I'll go ahead and rewrite it like that. Okay, now f of 3 is going to be 3 divided by x squared, but now x is 3. So I have 1/3 out of that. Okay, or, 1/3. Do I want to write it as 1/3 or do I want to write it as 3/9? I guess I'll write it as 1/3. That'll probably be easier. Okay, so now I'm going to put these pieces in the right places. Let's color code them. F of x plus h, or f of 3 plus h. That's going to be this part. That's going to go in there, in that position. I'll write that. Like that. And then I'm going to subtract. And then I need the other part. Then I need f of 3. That is this. So that's going to go in there. 1/3. That whole thing is still going to be divided by h. We're still going to be taking the limit as h approaches 0. Whew. Okay. Now we have a limit to work with. At this point, we've set it up. Now this limit may as well be like something that we saw back in chapter when we were studying limits originally. Okay, so let's kind of zoom in on that. What could we do here? Bit of a complicated rational function sort of limit. We need to simplify it so that we don't have a compound fraction anymore. So what I would say is let's multiply everything by 3 and by 9 plus 6h plus h squared. That's going to cause the denominators to cancel out. So I'm going to multiply the numerator by 3 and by 9 plus 6h plus h squared. And of course, if I'm going to multiply the numerator by that, I need to do it in the denominator, 3 times 9 plus 6h plus h squared. There we go. So now those multiplications are going to get distributed. And I guess there's no distributing to do in the denominator. Just multiply that by h. See what we get. It's going to start getting long, so I'm going to come down here. All right, so we have in the numerator 3 times 9 plus 6h plus h squared. So I'm going to, focusing just on this first red term, in the numerator, I'm going to have this 3 times all that. So I'm going to have 9 times 9 plus 6h plus h squared. The denominator of that is still going to be 9 plus 6h plus h squared. All right, I know you can see there's going to be some cancellation. We'll get to that in a minute. The second term, the blue one, 1 times all that. So that's going to be 1 times 3 times 9 plus 6h plus h squared, and then divided by denominator, which is 3. Now, all of that, that's the distributing. All of that is still divided by h and inside of my limit. Okay, now let's do the canceling. This is going to feel much better. Yes, that 9 plus 6h plus h squared matches this 9 plus 6h plus h squared. That cancels out. And that leaves us with just 9 in the first term. This 3 cancels with this 3, leaves us with this 9 plus 6h plus h squared in the second term. Now let's write that out. First term, 9, minus second term, 9 plus 6h plus h squared. Now, since I'm subtracting all of that, I'd better put it in parentheses. I'm subtracting the entire thing. And as you may remember, when you subtract a bunch of something which has a lot of terms, you need to distribute that negative across the terms. Okay, we'll do that in our next step. So, performing that distribution, we get 9 minus 9 minus 6h and then minus h squared. Great, all over h. Now, yes, you'll notice there's even more simplifying to happen in the numerator. Oh, hang on, is this all over h? No, shoot. You were probably thinking, half of you were probably thinking, Tristan, you forgot something important. I did these distributings in the numerator, but I forgot to do this part in the denominator. I forgot to actually multiply the denominator by 3 and by 9 plus 6h plus h squared. Oh, there we go. Let's make sure we get that in. You may be wondering, Tristan, why aren't you actually doing that multiplication? But I did do the multiplication, I wrote it. Look, I wrote times. I did the multiplication. I just didn't distribute anything at all. I didn't write 3 times h. I didn't distribute the h or the 3 across that sum. That's fine. We don't need to do any of those things. Let's write it one more time here. In the long run, because we're trying to get the limit as h approaches 0, it would be nice if we could cancel out an h factor, because right now we still have, if you hadn't noticed, we still have 0 divided by 0 if you would direct substitution. So I'm keeping that h factored out so that I can cancel it later. All right, let's get back to what we were doing. Notice the 9 minus 9 is going to cancel out. And so that leaves us with a nice, simple numerator. What do we have in the numerator? Got negative 6h minus h squared over h times 3 times 9 plus 6h plus h squared. All right, we're doing great. So now, if I look closely at that numerator, every term that still remains has at least one factor of h. So what I can do now is factor out an h, leaving me with negative 6 minus h times 3 times 9 plus 6h plus h squared. And now finally I can take the h's and cancel those h factors. Awesome. So we're almost done. We have negative 6 minus h in the numerator. We have now, at this point, finally, I'm going to go ahead and distribute the multiplication by 3. So I have 27 plus 18h plus 3h squared. Just a moment. All right, so this equals, well, finally, we can apply direct substitution. At this point, we can finally do direct substitution. Let's take the h here. That's going to be 0. That's going to be 0. That's going to be 0. All those are going to be 0 as h if we do direct substitution. Final result here is going to be negative 6 over 27. which reduces to, yes, -2/9. And that -2/9 is the slope of the tangent line. It's the derivative of the function f at 3. So I'm going to pause the video there and we'll finish it up in a moment. Okay, I'm back after a brief pause. No time at all for you, I bet. But here, now that we've done the derivative, okay, this was doing a derivative. We've done the limit of the difference quotient and found the slope of the tangent line. This is an analytical approach, by the way. In the past, we've done this sort of thing numerically by estimating, but here we have the exact slope. Now that we've done this, we're going to go ahead and use it. Let's find an equation for the tangent line at A. So A, in this problem, A equals 3, and f of A is equal to, we did that earlier, f of 3, that was 1/3. So the point that this tangent line is going to pass through on the graph of the function is the point 3, 1/3. And then the slope of the tangent line is what we found before, that we found via the derivative. Slope is f prime of 3, the derivative of f at 3, which is -2/9. So now we can take these two pieces of information and put them together in the point slope form of the equation of a line. This is review. We've already done this. Y minus y1 equals m x minus x1. All I need to do is say y minus 1/3, which is our y coordinate, equals -2/9, which is our slope, times x minus 3, our x coordinate. And that right there is a lovely equation for tangent line. We do not need to go further. We don't need to put this in mx plus b form. You certainly can if you want to. I wonder what you get. Plus 2/3 plus another third is plus 3/3. So it's actually +1. So that's a nice simple, I think I did that arithmetic right. You can check my arithmetic on that from my algebra. You can always take a point slope form and convert it to slope intercept form just by solving for y. But as far as I'm concerned, point slope form is just fine. There we go. We went through the process of taking a function, finding the derivative at a point, and then also finding the equation of the corresponding tangent line.